So now on to the more mundane stuff, I guess. My windows are still booting, so I can't show you right now, but I'm like pretty much 100% sure that the integration of diff7a, I mean the Excel plugin request diff7a now works, and it's actually correct, probably. Like we have test cases generated from basically poking the ATO calculator like over and over, going through all the possible options in the form, adding random repayments, just clicking through all the possible loan years, all the possible term lengths, and so on. There's like 160,000 test cases that you can see. You can see the data. So this is the code that like automatically clicks through the form, then a conversion into our test case request format, and then these are the generated test cases. But the limitation here is that these are all single year requests. Like that's the limitation coming from the ATO calculator, obviously. So that's one part, and these are all passing, I think. Rerunning, still finishing rerunning these right now. And then we have a bit of code for generating what I call multi-step test cases. So this works by coming up with some, where is it? Like in an iteration, you know, trying each year, each term length, coming up with some random data. And then, you know, getting the result for the first year. If it doesn't end in you know, a shortfall or something, or doesn't end with full repayment, then we go for the next year and the next, and until we get to the final year or the final balance, and we write that as a multi-year test case. So the output of the final of the calculation for the final year should exactly equal to the output for the multi-year calculation for that final year. So that's another way that I try to verify the implementation. But like there could be there could be corner cases or some interactions between the requests that I do not realize or something. So not even this makes it like, to me, like 100% sure that it's correct. Another thing to note is that the ATO calculator has some, to me, quite strange semantics of the result calculations. Like, I don't know right now. You're not gonna see you're not gonna see like total interest repaid when you get a shortfall, even when you did repay some interest or something like that. I don't remember now, sorry. So our calculator is made to match that exactly, but it gets kind of weird in some corner cases. Another thing to note is that I did write an RDF template for interacting with the Division 7A calculator, and I wrote some code that should allow the template to be used, but there's at least still a bit missing in the OneDrive, the web page where you can trigger the calculator. So I need to add like another button there, I guess, to make it possible to use that. So until then, it's probably only the Excel plugin if it still actually works. So that's that. So this is the possible RDF interface. This is the old Prolog implementation. Like what the robust server does currently is it, even if it receives a request on the like basically JSON request on the front end server, it issues it synthesizes an XML request, because I tried to stick to the XML format to change as little as possible so that I'm not working with too many moving pieces at once. So we synthesize the XML request and we go through invoking the calculator with all the status pages and all that. It's good. And we invoke the Prolog. It it reads in the XML like it used to, maybe with some adjustments. And then we have the option to run the old calculator and do the old calculator in Prolog, and to actually compare the results. Oops. That was quick reacting. I have the test still running in the background. So we have the option to compare the results, but I just commented this out when I ran into another problem with the alt implementation. Like, the first problem is that I think it wouldn't run some single year calculations. Like, it does better with the multi-year calculations. But then I also found a problem where I think interest calculation, I left a comment here somewhere. Interest calculation was like 1 day off. And again, it wasn't like an easy fix. When I just fixed the date, it wouldn't find the record at all. And like I said before, it's just hard to make sense of this code. And until we have a clear plan, a need to use this in some like a more logical setting where we're like trying to fill in the blanks, probably with the new engine, I don't know. This old code doesn't seem like it's even useful for verifying the new implementation right now. I'm not sure. And just for completeness, this was my original attempt at re-implementing the calculator in Prolog. But then I decided to switch to Python. It made more sense. We have the visualization. We don't have to like wrestle with the control flow because we're doing just imperative step-by-step logic. I mean, code anyway. So the final thing to show is probably to go back to the test cases to give you an overview. So here we have the automated multi-step test case generator. Here are the test cases, most of them still not committed to the repository, but they all seem to be, the tests seem to be passing. But like, I'm still, I cannot be sure that everything's correct. Actually, I'm pretty sure that the code is not gonna fare well when you submit like a negative repayment, and there could be more corner cases in combinations of inputs that I couldn't think of yet. But we do have the ATO calculator auto-generated test cases. We have the multi-step test cases. We have some test cases for invalid inputs, like invalid lodgement date. Example of an invalid lodgement date. Specified 1 year too late, basically. So you are gonna get a good error message for that. We have some manually created multi-year test cases these are verified step by step. These are like, I think, 2 year test cases verified by doing the 2 steps manually in the ATO calculator, and the outputs of the calculator are copied here. One, another, and then the results are manually compared to the expected output XML. And then we have some old single step ones. Wonder what's up with the 2025 here, but we're doing the calculation for 2019, so all the remaining repayments are probably just ignored here. This is maybe something to think about, the interaction, the possible interaction between what is the calculation year and some kind of feedback to the user, or some kind of being able to specify if the user believes they are providing like a complete list for the whole loan or what part of the loan. They're not sure about that. Maybe a thing for ChatGPT again. So these are all more or less old test cases that we've had from before. Paying too much, paying too little, maybe. It would seem we paid just the right amount here. Closing balance is 0. Shortfall is 0. I think I need to look into this one. So 2014, always unsecured, 7 years. Inquiry year is 2000. Inquiry income year is 2015. Then we have the funny value here. 1505 2015. And then we have the repayments. Next one is 5 days later. I've put this test case into the calculator before, maybe more than once. So 16. No. Oh, 1607. 214. We have 100,000 AUD. And yep, that's what the calculator says. You have minimum yearly repayment of minus 17,000. blah blah blah, total principal, like, I don't know, it doesn't make a whole lot of sense that you repaid 100,000 in principal when you had a loan for $123, but that's the logic here. And we match it in our test cases. Total principal, total interest, closing balance 0. Never mind the 0.8 here. That was a bit of an error when I was generating these test cases, but it's like within the rounding error anyway, that we have to, when we compare with the ATO calculator, or I mean when we compare with the saved test cases, we have to provide for some rounding error. So that was that. 2 repayments on the same date, another interesting corner case. Like I was saying, there could be more funny inputs like this that we may or may not handle correctly still. Yeah, that's